Hello everyone, welcome back. In this video, I am going to teach you the hierarchical clustering. Hierarchical clustering is nothing but it uses the hierarchy. What is this hierarchy? We will understand this. One more point here is no centroid. No centroid in the cluster. There is no centroid in the cluster. In K means we had the centroid. Here we don't have the centroid. What is the hierarchy? Hierarchy should be like A, B, and C, X, D, E, consider F, J. So this has some hierarchy, right? Like great grandfather, grandfather, then children. This has hierarchy. Or in this way, it is also a hierarchy from top to bottom, the opposite way, bottom to up. So we have hierarchy. So hierarchical clustering uses this top to bottom or bottom to up approach for clustering to create the clusters. If it uses top to bottom, it is known as agglomerative clustering. Agglomerative clustering. That is bottom up approach. Bottom up approach. And if it uses top to bottom, it is known as divisive hierarchical clustering. It uses top to bottom approach. Okay, let's learn both of these hierarchical clustering methods. First, we will learn the agglomerative. Our Scikit-learn library uses the agglomerative hierarchical clustering. Our Scikit-learn library uses this. This is very important to remember. Whenever we build our model, we use a Scikit-learn. We mostly use a Scikit-learn. So Scikit-learn uses agglomerative hierarchical clustering. So how this clustering work? Step 1, create cluster for each data point. It will create cluster for each data point. I mean, consider we have data points. We have 4 data points: A, C, B, and D. Okay, B and D. So for each data point, it will create a cluster. For A, it is cluster 1. For C, it is cluster 2. For B, it is cluster 3. For D, it is cluster 4. For every data point, it will create one cluster because it is a bottom up approach. We start from scratch. Bottom up approach. With each data point, it will create one cluster. Now in step 2, it will calculate the distance between each cluster. Will calculate the distance between each cluster. We have 4 clusters now: A, B, D, and C. Okay, C1, C2, C3, and C4. It will calculate the distance of A with B, of A with C, A with D. Every data point it will calculate the distance: B with D and C with D. So all the distance it will calculate. If you see in this diagram, A and C are near, right? A and C are close to each other, and B and D are data points are close to each other. So step 3 is merge clusters with minimum distance. Merge clusters with minimum distance. So these two clusters are close to each other, and these two clusters are close to each other. So it will merge those clusters with minimum distance and form clusters. What will happen here? We have data points A, C, B, D. So distance A to C is minimum and BD is minimum. So it will merge these and form a new cluster. Now there are two clusters. Okay, now there are two clusters. This is C1 and C2. First we had 4 clusters, C1, C2, C3 and C4. Now we have 2 clusters, C1 and C2. Step 3 is repeat again. That's all. Again it will calculate the distance between each cluster. That is, we have only 2 clusters. It will calculate the distance and it will merge, because this is the minimum. We have only 2 clusters, then that distance is minimum. Now it will form one large cluster. Repeat until you form one large cluster. So finally we have data points A, B, C, D, E, and this is our final cluster. One big cluster, only one cluster. So this is agglomerative approach, that is bottom to up approach. From bottom, with each data point we will create one cluster, and then we will start calculating the distance and merging the clusters to form one big clusters. This is agglomerative approach. Sorry about it. Okay. This is agglomerative approach. And for distance, this point is important, remember this. For distance, it uses word linkage. To calculate the distance between the clusters, it uses word linkage. Word linkage is merges the clusters that causes the minimum increase in WCSS. Let me write. Merges the clusters that causes minimum increase in WCSS. WCSS is nothing but within cluster sum of square. That is inertia. I have explained this in the previous video. Okay? That is nothing but inertia. Sorry for the wrong spelling. Inertia. That is nothing but the inertia. So how it merges the cluster? Using the word linkage. It is not ward, W-A-R-D, word linkage. This point you have to remember. Next we will learn about divisive clustering. Divisive clustering. See, this is very simple. This is top to bottom approach. Agglomerative is bottom to up. This is top to bottom approach. This was bottom to up approach, but divisive is top to bottom approach. So what it will do is, if we have 4 data points A, B, C, D, will form one big cluster. At step 1, it will form one big cluster. Then at step 2, it will find the points which are far from each other. Then it will form subclusters. First it was only C, then it is C1, C2, and next it will keep repeating this. It will keep repeating this until you reach the point where each data point is a separate cluster. Where each data point is a separate cluster. Opposite of agglomerative. That's all. From top to bottom. From top to bottom. From one big clusters to subclusters until it reaches as many clusters as many data points. That is the idea of divisive hierarchical clustering. That's it. It is same. So you are clustering here in both agglomerative and divisive. You are forming the clusters. Consider the agglomerative. Consider the agglomerative example. Same example we will consider. Okay. Agglomerative. We have 4 data points. A, C, B, D. So agglomerative, what it will do? It will first form clusters for each data point. Then it will form merge nearest data points and form clusters, and then it will form final one cluster. So when to stop this? In real world, we will not have only like 4 data points or 3 data points. So when to stop? According to me now, if I form only 2 clusters, that is a good clustering. I can predict my data very well because these 2 clusters are far from each other and data points are close to each other. Compactness and cohesion. Compactness and cohesion. I have explained this in the Silhouette square, if you remember. Okay, compactness and cohesion is well here. It is good enough. So according to me, I should form 2 clusters. But agglomerative, it will keep on forming until it will form one big cluster. So when you have to stop agglomerative model, when to stop agglomerative model forming a clusters. When to do this? How to find that? That means what is the optimal value of number of clusters? What are optimal not say value, what are optimal numbers of clusters? How many clusters I should form for my data? What is optimal number of clusters? So in the hierarchical clustering, there is a method known as Dendrogram. The K means we have used inertia and elbow method, Silhouette score, but in agglomerative hierarchical clustering or divisive hierarchical clustering, we have method to find the optimal number of clusters is known as Dendrogram. Dendrogram is tree-like structure. We visualize dendrogram, it is a tree-like structure. Okay, it will start forming the clusters where x-axis and y-axis will plot a tree-like structure on x-axis and y-axis. I will x y. So x-axis is data points, your data points. Okay, and y-axis will be the Euclidean distance. Y-axis will be the Euclidean distance. If you don't know Euclidean distance, you have to go through the video of distance matrix in clustering. The previous video I have explained the Euclidean distance. So what does this dendrogram does is will form the clusters. Suppose I have data points A, C, B and D. Okay. So my first cluster will be A and C, B and D, separate for each cluster. Then what I have done, I have joined these two, formed one cluster, and joined these two and form one cluster. And then what I did, I joined both the clusters to form one big clusters. So if you see this distance, this line, vertical line, that is y-axis. Let me change the color of this. This line, it is the distance, Euclidean distance, because y-axis is Euclidean distance. This is also distance. This is also distance. This line is also distance. So if it is smaller distance, you see in this diagram, these line 1, 2, 3 and 4 have smaller distance. Smaller distance means similar clusters. Smaller distance means similar clusters. If you see this line, it is large. That means large distance. This line 5. This line 5 has large distance. So this line is the distance between the cluster AC, cluster BD. This C1, consider this is C1 and this is C2. So it is the distance between these clusters. So what this line is saying is, distance between two clusters. For A and C, the distance is less. For A and C, the distance C, this distance is less. For B and D, this distance is less. But for the cluster C1 and C2, if I join A and C and join B and D and compare these two clusters, distance between C1, C2, this is C1, this is C2, then distance is large. That means larger distance is dissimilar clusters. Larger distance is dissimilar clusters. Okay. So using this diagram, we have to find the number of clusters. How to find that? We had data points A, C, B, D, and this was our dendrogram. So when you see such a long lines, such a large distance line, then you should draw a vertical line like this. Vertical line like this. Okay. To draw a vertical line like this and count the number of horizontal line it is cutting. You see here how many lines this green dotted line, vertical line is cutting, horizontal line is cutting. Line 1, this is line 2. So it is cutting two lines. It is cutting two lines. That means cutting two lines. That means optimal number of clusters, optimal number of clusters is equal to 2. Optimal number of clusters is equal to 2 because it is cutting 2 lines. This line is cutting 2 lines. So the optimal number of clusters is 2. For better understanding, I will show you the practical. I have designed a dendrogram for you. See here. I have created this data set. Okay, this is not our original data set where we are going to build our agglomerative hierarchical cluster model. This is a dummy model. This is a dummy model I have created to explain you the dendrogram, where I have customers A, B, C, and D up to H, their annual income and spending. I will do clustering on this. If I visualize the data, our data looks something like this. This customer A, B, C, customer D, E, F. These are customer GH. If I visualize this, I can say we have to form 3 clusters, right? Cluster this ABC will be one cluster, DEF will be the another cluster, and GH will be third cluster. So we can form 3 clusters. So I will plot a dendrogram and check. By visualizing I am saying, but in real time we will have lot of data set. But we can't just visualize and say how many clusters we should, what is the optimal number of clusters. We have to use the dendrogram. Let's see, let's plot the dendrogram. See, this is our dendrogram. It is very clear here. See the dendrogram. X-axis is customers, data points, all my data points, and the y-axis is distance, that is Euclidean distance. If you see here, if you observe here, point A and point B. What is our agglomerative? First it will form cluster for each data points, and second point is it will merge, it will calculate the distance and merge the nearest data points to form a cluster. So at first step it has formed A, B has one cluster, GH has another cluster, DE has one more cluster, F and C, you see F and C, it has formed separate cluster for F and C. At step 2, it has merged cluster C with cluster A and B, and cluster F with cluster D and E. This is our second step. And you see these lines, see the orange line, the vertical line, the y-axis. It is very small, you can see here, orange lines. These are very small vertical lines, y-axis vertical lines, okay? See the green lines for G and for H, you see. These are very small. For F and D, it is again small. So the distance is less. That means smaller distance means similar clusters. So these points are in similar cluster. Now you see this line. This has found one more cluster now, agglomerative. G and H, and including all the points F, D and E, it has formed one more cluster. So these lines are very big now. Can you see these lines? These line is very large. That means distance is very large. That means they are not the similar clusters. They are dissimilar cluster. If you see the blue line also here, after forming one large cluster, blue line, it is very large. That means distance is very large. They are dissimilar cluster. So after this dendrogram, plotting this dendrogram, what we have to do is we have to draw a horizontal line which will cut the larger distance lines. Okay, larger distance lines. Here I have drawn the horizontal line, the red line. How many lines it is cutting now? Blue line 1 and 2 green lines, 2 and 3. 2 green lines and 1 blue line. That means the optimal number of clusters will be 3. If it is cutting 3 lines, then optimal number of clusters are 3. Got it? What is dendrogram? I hope you have understood what is a dendrogram. Yeah. Now let's do for our original data set. Okay? We will do for our original data set. Same data, I am continuing again with the same small customer data, where I am using the annual column and spending score, 2 features to form the clusters. Now let's do the hierarchical clustering, agglomerative. I will implement the agglomerative, okay, hierarchical clustering. Okay, I have drawn the dendrogram. This is the dendrogram of small customer data. We'll enlarge this small customer data. See, it has started forming here. It has started, if you observe at this point, it has started forming small clusters. For every data point, it is forming small clusters. So these all orange clusters are one cluster, and it has started joining them. So this is agglomerative. It is forming hierarchy. See the hierarchy, the orange line. See the hierarchy, how it is forming and joining the data points to form a one big cluster. Same thing it is done here with the green, red lines. These are different data points. X-axis is data points. So this is the hierarchy, how it is forming the clusters. Yeah. Now you see this blue line. The blue line, how large it is. Again, this blue line, how large it is. See the red line. See this red line, how large it is. From this point to this point. So these are large lines, right? So from this dendrogram, we have to predict the optimal number of clusters. That is, I will draw a line. Consider I have drawn the purple line now. Let's count how many lines it is cutting. 2 blue lines and 1, 2, 3. 3 red lines. 3 red lines and 2 blue lines it is cutting. That means the number of clusters are 5. So the optimal number of clusters are 5. I should use k value as 5 to build my agglomerative clustering. Okay. The purple line I have drawn, it is cutting 5 lines. And see the code here. I have from Scikit-learn, I have imported agglomerative clustering because Scikit-learn does not support divisive clustering. It supports only agglomerative. So from Scikit-learn, I have imported agglomerative clustering. Okay. And then I have defined my model with n clusters as 5 clusters. And linkage, see, I told you, right? Linkage has word. It will connect the clusters which has minimum increase in the inertia, that is WCSS, within cluster sum of squares. So I have defined my linkage, how to connect the clusters on the basis of word linkage. I have specified this parameter, and I have built my my agglomerative model. And if I visualize how it has done the clustering, so it has formed the 5 clusters, 1, 2, 3, 4, and 5. That's all for today. So this is hierarchical clustering. I hope you have a good experience learning the clustering algorithms with me. Thank you for watching.